Yeah, welcome back. Let's continue with our topic of organic chemistry. And today we are going to discuss about isomerism. We are going to discuss, or we are going to start our discussion by discussing about isomerism. So by definition, isomerism is an occurrence of compounds or molecules with the same molecular formula but different structural formula. Occurrence or existence of compound or molecules with the same molecular formula but different structural formula. So I hope you have a little concept of isomerism from your O-level organic chemistry. But if you don't have it at all, no problem. We may have two or more organic compounds having the same molecular formula but different structural formula. The number of atoms in both two organic compounds is the same, but the arrangement of the atoms in the molecule is different. Now, these two compounds, we call them as isomers. Now, we have two types of isomerism. We have a structural isomerism and a stereoisomerism. Structural or constitutional and stereoisomerism. Starting with the structural isomerism, zenyewe zinatokana na kuchange kwa muundo wa hiyo compound yetu. So structural isomerism zinatokana na kuchange kwa muundo wa compound yetu. Kwa hiyo ninavyosema muundo ni nini? It can either be the change of functional group, changing the position of functional group, or changing the position of carbon. Kwa tunasika tuna compound mbili ambazo either tuna change functional group au nyingine tuna change functional group ilipokaa. Tunatoa kwenye carbon moja na peleka carbon nyingine. Au nyingine tuna change carbon zilipokaa. So is an existence of compound with the same molecular formula but different arrangement of atoms. Same molecular formula but different arrangement of atoms. Or covalent bonds in the molecule. This kind of isomerism leads to the formation of structural isomers. And in this kind of isomerism, which is structural isomerism, we have three different types of isomers. We have functional isomer, positional isomers, and skeletal or chain isomers. Functional isomer ni nini? Positional isomer ni nini? Na skeletal isomer ni nini? Functional isomer ni ile ambayo tunabadilisha functional group. Kwa mfano, tukawa tuna CH3, CH2, C double O H. This compound is an aldehyde. Na ukiangalia hiyo compound hapo ambayo ni aldehyde ina carbon 3, then ina hydrogen 3, hizi hapa zitakuwa 6 pamoja na oxygen 1. Sasa huyu ni aldehyde, tunaweza tukachange functional group kwenda kwenye ketone akawa CH3 C double O then CH3. Hapa unakuja kuona carbon zinabakia 3, hydrogen 6 na oxygen 1. So this is the ketone. Kwa hiyo hii tunaita functional isomers. Hizi mbili tunaziita functional isomers. Tumefanyaje hapa? Hapa tumechange functional group. The number of carbon, hydrogen, and oxygen atom remaining the same, but we have changed the functional group. That's why tunaita functional isomers. Lakini hii inaitwa functional isomers. Lakini kwa mfano unaweza kuwa na CH3, CH2 hydroxy. Hii hapa ni alcohol, ambayo hydroxy hapa iko kwenye carbon ya kwanza. Mimi nikiandika CH3 CH hydroxy CH3, hii pia ni alcohol. ambayo hydroxyl liko kwenye carbon ya pili. This will be called as the propanol. Lakini hii tunaweza kuita kama ni 2 au tunaweza kuita kama ni propan 2-ol. Hii itakuwa ni propan 1-ol. Maana yake hapa hydroxyl imekaa kwenye carbon ya kwanza, hapa ya pili. So hii hapa tunaita positional isomer. Positional isomer kwa sababu tumechange position ya functional group. Lakini functional group yenyewe imebakia ile ile. Lakini pia mwingine anaweza kawa labda na CH3, CH2, CH2, CH3. Huyu hapa akawa ni butane ambaye anajulikana ni carbon 4, hydrogen 10. Mwingine anaweza kaandika CH3, CH3, CH3. Na huyo akajulikana kama ni 2-methyl propane ambaye ni carbon 4, hydrogen 10. So butane na 2-methyl propane zitakuwa zinaitwa kama ni skeletal isomers. Why? It is because tumechange skeleton. Hapa ilikuwa straight, hapa tumeweka hiyo branch. Kwa hiyo ni skeletal position, tuna change position of the same functional group. Functional, tuna change functional group. So hivyo ndivyo ambavyo hizi isomers zinakuwa zinaenda by that way. So tukianza na functional isomers tumesha discuss kwa nyuma, so hapa nafanya tu review. Functional isomers are molecules with the same molecular formula but different functional group. Example, propanone and propanar. Propanone, which is ketone, and propanar, both have their molecular formula C3H6 and O. Ambayo ni kutolea mfano kwenye hii paper hapa, propanone pamoja na propanar. So huyu na huyu kilicho change ni functional group. Huyu ni ketone, huyu ni aldehyde, lakini number of carbon and hydrogen atoms mbaki zile zile pamoja na oxygen atom. Namba 2 mfano ni ethanol na mesoximethane. Pia tuna cyclobutane, mfano 3 cyclobutane and butene. Kwa hiyo hizo ni mfano tu wa functional isomers. Positional isomers are molecules with the same molecular formula but different position of functional group in a molecule. Example ni but2-in na but1-in. Kicho tofautiana ni position of hiyo alkene group. Then example ni hapa propan-2-ol, propan-1-ol na propan-2-ol. Lakini pia tuna chain or skeletal isomers are molecules with the same molecular formula but different arrangement of carbon atoms. Kwa hiyo chain isomers, tunasema organic molecules are based on chains of carbon atoms, and for many molecules this chain can be arranged differently, either as continuous chain or chain with multiple side groups of carbon atoms branching off. Kwa mfano hii ni butane, lakini hapa ni 2-methyl propane. Zilicho tofautiana hapo ni chain ipoje. Now from there we can move to the second group of isomerism, which is stereoisomerism. Stereoisomerism, the type of isomerism in which the isomer have the same connectivity but different spatial arrangement of atoms. Yani bondi ni zile zile ila spatial arrangement of atoms ndio imetofautiana. In this group we have two types of isomers, in which we have geometric isomerism and optical isomerism. Starting with the geometric isomerism is an existence of compound with the same molecular formula but have different spatial arrangement of atoms or group of atoms on either side of the chemical bond or ring structure. Different spatial arrangement of atoms. So these compounds with the same molecular formula but different spatial arrangement of atoms or group of atoms on either side of the chain of the chemical bond or ring structure, they are called as geometrical isomers. This is more common in alkene. For example, this is what you call the cis-but2-ene, and this is trans-but2-ene. The cis isomer in a alkyne group, but the trans in alkyne group down, alkyne group nyingine iko up. Unaona how trans imekaa, lakini cis imekaa, trans imekaa. So kuna tofauti kati ya cis na trans isomers hapo. Utaona kuona uko mbele kwenye nomenclature. Hizo lazima uziweke kama mpewa compound kama hiyo. Lakini the second type we have optical isomerism. Optical isomerism is the existence of compound with the same molecular formula and they are the mirror image of each other. Optical isomers are molecules which have the same molecular formula and a mirror image of each other, but they differ in arrangement of atoms. So, looking at these two compounds, unaweza kuona kuna methyl hapa, kuna methyl, kuna hydrogen, kuna carboxylic group. Huku hii imekuwa ni kama mirror, tukiweka kama kioo hapa, huku ina reflect methyl iliyokuwa kushoto huku atakuwa kulia, alafu kuna carboxylic group pamoja na hydrogen. So we have other terms ambazo zinatumika kwenye organic chemistry, kwa mfano structural formula, the type of chemical formula which show the actual chemical number of each type of atom present in the compound and how they are arranged or bonded to each other in a compound. Structural formula ambayo inakuwa inaonekana kama hivi, inaitwa open structural formula. This is condensed structural formula. But we have other categories of structural formula also, kama hizo hapo nazo ni structural formula. Hii hapa pamoja na hii hapa, this is open, this is condensed. We have molecular formula, the type of chemical formula which show the actual number of atoms present in a compound or molecule, bila kuonyesha arrangement yake. So structural formula inaonyesha the actual number of molecules, atoms, and their arrangement. But the molecular formula doesn't show the arrangement. We have the saturated hydrocarbons. The hydrocarbon in which each one of all four possible bonds of every carbon atom is joined or linked to another carbon atom or hydrogen atom. Saturated hydrocarbons are also known as alkane. Lakini we have unsaturated hydrocarbons. Unsaturated hydrocarbons is a hydrocarbon that has at least one double bond or triple bond between its adjacent carbon atoms. Then you have the concept of homologous series. Homologous series is the series of compounds of the same family and share the same general formula and have the same chemical properties but different from one another by methylene group, which is CH2. So members of a given homologous series, they always possess some characteristics. I know you know some few examples of homologous series of alkane. So you know different homologous series, lakini members of the same homologous series wanakuwa na features fulani kama ambavyo tulisoma kwenye form 4 organic chemistry. Lakini kama ukumbuki, cha kwanza, all members of the same homologous series, they must have the same general formula. Alkane wana general formula yao, alcohol, wote, kila homologous series in general formula yake. Cha pili, all members in a homologous series have similar chemical properties. Yani kama zina react kutoa water na salt, basi zote zitafanya hivyo hivyo. Ya tatu, all members of homologous series have similar method of preparation. Number four, all members of the homologous series have similar functional group. This is why they have similar chemical properties. And number five, members of a given homologous series show a gradual change in physical properties, such as boiling point, melting point density, etc. This is because of the increase in strength of intermolecular force of attraction. Kama tulisoma kwa general chemistry, the van der Waals force's strength increases with the increase in molecular mass. So the molecular mass increases, the strength of van der Waals forces tend to increase, and so increasing the or changing different properties of the compound. So note that the compounds which branched has a low boiling point and melting point than straight chain. That's because of the surface area. As the surface area decreases, the strength of van der Waals forces tend to decrease. But as the surface area increases, the strength of van der Waals forces tend to increase. Number 6, every member of homologous series differ from member that is above or below it by methylene group, which is CH2, such as huyu hapa na differ by carbon moja. Kuchukua hii toa utapata carbon moja, hii toa utapata hydrogen mbili, na huyu vile vile. So in hydrocarbons we have alkane, alkyne and arenes, which are benzenes. Na kama ambavyo tulisoma kwenye introduction tuichambua sana how the double bond is formed, how the triple bond is formed, types of hybridization ni carbon, repeat vile vitu tavona kwanza discussion ya alkane wewe tayari unavifahamu kichwani.